Right, next topic is IPv6 in the overlay. So Keisha will be co-presenting with me on this topic. I'll be covering the overview, use cases, hand over to Keisha for details, caveats, configuration, troubleshooting resources, and even the demo actually. He has his own setup, so we'll let him drive that. Okay, so overview. So 10.5 did not support IPv6 unicast routing in the overlay. Right now we do support it in 10.6 on all these platforms. So what's new and related to this IPv6 in the overlay? We support it in both centralized and distributed gateways, but obviously we recommend this distributed gateways for most customers. The gateway SVIs will support Slack for client assignment, only Slack. No DHCP-v6 relay in 10.6. And if you do need to, we support IVRL for IPv6 unicast. IVRL stands for inter-VRF route leaking. Use cases. In a data center, you can see here, it's typically dual stack in the overlay. Right? You have SVI, active gateway with link local. It's the same on multiple VTAPs, as well as the IPv4 default gateway. And in the underlay, most customers only want to run IPv4. So IPv4 only underlay, but dual stack overlay that supports both. So this will do both L2 and L3 across the racks for both IPv4 and IPv6. For servers, they can either use static IPv6 or Slack for client addressing. And you can communicate with an external non-overlay network using this border. You can route between those stacks. Unicast. In the campus, that's what we see as well with distributed gateways, with dual stack. And the clients typically will use Slack, right? They do not have static IPs normally for v6. So this will enable dual stack for the clients to get out on the border to the non-overlay network. Okay, details. Kishore, there?
Oh, yes, Daniel.
Okay, I'll stop sharing. Go ahead. You can share your screen.
Yeah. Uh, can you see the screen?
Yeah, I see it. Thanks.
Yeah, the underlay is still IPv4. So because of this, entire underlay network need not be changed. So it eliminates the needs for deployment of IPv6 underlay network. So the solution is based on the standard RFCs and drafts. So type 2 route is details are actually present in RFC 7432. So the encapsulation of IPv4 and IPv6 are very generic. Based on the length field, it would be decoded. So coming to type 5 route also, it's a similarly, it's a very generic format that is specified in the draft prefix advertisement level. So AOS-CX, we actually support pure type 5 route, which means the overlay next hop or there is no overlay next hop or type 2 route for recursive route resolution. This is the same case as in IPv4. So there are a few of the caveats actually. So the IPv4 and IPv6 active gateway max should be same. And coming to the physical IP and gateway IP also should be different, even for V4 or V6. And currently we do not support DHCP V6 relay. It's planned in the future releases. And in the IVRL scenario, whether you import or export actually like to or from actually EVPN VRF to the non-EVPN VRF, you should configure both import route target and export route target.
Hey, Kishore, I forgot that I was supposed to present the configuration portion. So if you
Yeah,
want, I
yeah.
can take over that.
Yes, please.
Okay, yeah. So I'll share again for this section. You can stop sharing and I'll share. Okay, I'll cover the configuration and hand it back to Keisha for troubleshooting. Configuration wise, basically it's all in the overlay. Right? No change for your underlay IPv4. So on your SVI, you have your dual stack and you have your global unicast address as SVI IP here. The active gateway IP will need to be link local. Okay? So from all the RA, the client will know they're supposed to get both the link local subnet and the global unicast through the Slack. Okay, you can assign your DNS server and search list, etc. Under the router BGP, so EVPN config is the same, no difference, but it's VRF specific. You can see here now, there's address family IPv6 unicast, where you want to redistribute connected for the type 5 routes. So this means the global unicast will be advertised out when you do this redistribute connected. You can see the VM will get both a link local as well as the global unicast address when you configure this way on the SVI. How you validate? You're still using ARP. You do show IPv6 neighbors with the VRF. You can see the link local as well as the global unicast address for the same MAC address. This MAC has multiple global unicast addresses, right? Because it's Windows, many are temporary. Okay, it's local. And how you validate? On leave one here, you can see the subnet from the next hop remote, and you can also see the /128, which is the host route of this VM from the next hop. So again, if leave 2 learns about this entry, he will actually advertise it out because of the distribute host route command in the config. Okay, this is through the type 5 redistribute connected. He advertises this information out. IVRL on the border, this is the border, leave 1. You can see here I have the tenant VRF1. I also have a services here that's linked to this link to the non-overlay network. And typically between the same tenants, you can see we're going to import and export the same values, 65001:1. So the leave 2 will learn all the leave 1 VRF1 routes. The difference now is IPv6 address family unicast under this border. You can see here we export 601. That means in your other VRF, you want to import this value, right? You export 601, you import 601 here. And in this services, you want to export out 605, and you want to import 605 in this VRF1. So this way, you control which routes are being sent out and which routes are being learned between the 2 VRFs. This is route leaking, right? So when this is done, leave 2 actually learn whatever is in here, the services, the routes. So that's route leaking. That's also used by the remote VTAPs, but they do not need to configure the route leaking, right? They just learn it from the border. So the objective is to learn this remote route in the non-overlay network on this leave 2 through this route leaking. So on the border, you can see here, show IPv6 route, VRF services. On this guy, leave 1, you can see this is the remote route via services VRF. This is the next hop here. If you look at the VRF1, which you leak to, VRF1 you can also see this unicast route via VRF1 now. So VRF1 knows about it, but it's through services. If you compare it before, it's via service, VRF services through this next hop. If you leak it on VRF1, you can see it's through the services VRF next hop. That's leave 1. If you go to leave 2, you can see here this route, remote route, has a next hop of 11.3, this VTAP next hop. via VRF1. So we have shown that this is how leaking is confirmed. IVR is confirmed. Troubleshooting, hand over back to Kishore. I see a question in the Q&A. Let's see. Can we do IRL with the default? Oh, not yet. So IVRL is only between the tenant VRFs. Right, Kishore, you want to share a screen?
Yes, Daryl, I'm doing that.
Yep, see your screen.
Coming to the troubleshooting, actually, IPv6 overlay is similar to IPv4 overlay host. And the following command is actually a collection of many of the commands which is useful for a dev engineer to troubleshoot any issue. That is diag evpn dump all. And then coming to here, troubleshooting, we do two parts to it. Actually, one is a configuration checklist and the show command checklist that we need to verify. So with respect to VXLAN component, just ensure the VXLAN interface is unshared and source IP is configured and reachable. As well, like L2 VNI and L3 VNIs are configured with the correct with respect to association of VLAN and VRF. And for the VRF, routing should be enabled. Coming to EVPN component, we need to check under EVPN VLAN is configured with the correct import and export route targets, and enable redistribute host route, which is applicable for the same for whether v4 ARP entry or NDMD entry redistribution as a type 2 route. And coming to the VRF RAD, associate with the EVPN suffix that route targets and export as well as import. With respect to BGP, ensure that neighbor is enabled under EVPN address family. As well, like send community extended should be configured. Typically, in a multi-RR route reflector scenarios, few of the RRs might not be enabled with by any chance. Still, we might not see exactly the same problem at that particular time, because on VTEP, which RR selects the path, based on that, the extended community would be effective. So ensure all of the RRs are configured with the send community extended. Similarly here, type 5 route under the VRF RED, under address family IPv6 unicast, enable redistribute connected for the connected network or OSPF or whatever the protocol the host route is. Coming to the VMAC, need to ensure virtual MAC is same on both primary and secondary in case of a VSX. Coming to the show commands, we need to ensure first that IPv6 neighbors that host neighbor is resolved and the physical port is populated. Similarly, the MAC is also for the type 2 route. In case of a overlapping VLAN case, ensure that MAC is also reachable under MAC address table. Coming to the BGP component here, check show BGP L2 VPN EVPN summary and check the neighbor is established. And in the show BGP L2 VPN EVPN table, ensure that L3 VNI for that particular route is received or advertised. Coming to the extended communities, ensure that whatever the extended communities you receive for a particular route should be matched against the import route targets configured on the VRF. Then only the importing of the routes would happen. Coming to the EVPN status, actually, if there are any of the configurations mistakes, then this instance may not show up. It shows a relevant error status here. So can verify show EVPN EOA summary. And the router max received, which is used for the internal header for the VXLAN packets for a particular VTEP, can be shown with this show EVPN VTEP neighbor all VRFs. And coming to the host MAC IPv6 in the EVPN table can be checked via this command show EVPN MAC IP, which is like here, if you see 101::2 is a remotely learned VTEP pointing to a VXLAN VTEP. Similarly, 100::1 is a locally learned here. L stands for the local and R stands for remote. So another command that we can check is show EVPN EVA details. So this will show like how many type 2 routes you received and as well as type 5 routes received. All the details can be found in this show command. So coming to VXLAN status, ensure that L2 VNI or L3 VNI is received from that particular VTEP, and it is the status is operational. And coming to the route table manager, in short RTM, can be checked whether that type 2 or type 5 route received is installed into that routing table. So here 101::2 is the remotely learned route, which is NCAP VXLAN and with a L3 VNI 10,000. So I'll share the demo topology now.
You stop sharing.
Oh, sorry. Can you see the screen now?
It's coming up. I don't see it yet. Okay, I see the screen. Yeah, but you need to swap the display. Or just don't do presentation mode. It's fine. You don't have to show.
Sorry.
Just show your desktop and.
Okay. Oh, still it is the same, or?
Yeah. Okay, now I see it correctly.
Okay. This is the topology I'm using for the demo. One RR or spine and two VTEPs. One VTEP is a VSX pair, and the other is a standalone VTEP. So for the underlay addressing, I am using 1.1.1.1 and 2.2.2 for the VTEPs. 3.3.3.3 is the RR loopback for the BGP neighborship. So for the overlay host, I would be using 100:::, and 101:::, which is connected to VRF red on both the VTEPs. On the interface VLAN 2 and VLAN 3 respectively on the VTEP 1 and VTEP 2. So I'm going to share the switches now. Can you see my VNC?
Yes, we can see.
This is the VTEP 2 host 2 connected to VTEP 2. This is the address assigned by Slack configuration done on the VTEP 2. So on the host one, I have configured static IPv6 configuration, which is 100::1. And so on the VTEP 1, I am showing the interface VLAN 2 configuration which is configured with the gateway address as 100::10, and on the this is configured with the Slack configuration with a gateway as 101::10. So I'm going to check the neighbor table on both VTEP1 and VTEP2 on the VRF, right? So we can see the neighbor is learned from the host 1. Similarly, on the VTEP2, so this is a learned, and few of them are actually linked local addresses learned from the same host. And we need to ensure this is there in the BGP neighbor table. With a L3VNA 10K, and this is the locally learned route. And similarly, this is like this is the whether this route is advertised to the neighbor can be checked via neighbor advertised route command. So this is advertised to the 3.3, which is a RRA here. So similar, we can see that route is advertised 100::1. And so let's check this on the remote VTEP. I'm checking the routes received 100::1, which is received, and we need to check um, the extended communities that is received with the with this particular route. So here it is like 65K:10, and so this is matching against these extended community. We are checking again as the import route target. So and then let's check in the show IPv6 route table that route is imported under VRF red. We can see 100::1 is received on this particular route, pointing to the tunnel 1.1.1.1, and with the encapsulation VXLAN and L3VNA 10,000. And let's check this tunnel is reachable. So for this destination, we have a VXLAN tunnel which is operational with VNA 10,000. Similarly, I'll check on the source on the VTEP1 as well for the host 2 entries. We can see this is the entry that is being received from the remote VTEP. And let's check end-to-end ping that. This is the host 1 entry pinging from the host 2. So on a similar note, actually, this is a dual stack we have configured on this SVIs, which is V4 also enabled on the VLAN 3 here. So we can see the routes of IPv4 as well. Which is 101.001. We can see that on the remote end, that particular route pointing to a 2.2.2, which is VTEP2, encapsulated with VXLAN and L3VNA 10,000. So few of the other commands that can be used for troubleshooting is one is show EVP and EVA summary whether that L2VNA and L3VNA instances are up. And similarly, like whether this particular router MAC is received along with the routes can be checked via VTEP neighbor. And this show EVP and EVA details can show like how many VTEP local max learned, remote max learned, and type 5 routes learned and advertised. So, and finally for the show EVP and MAC IP, we can see this neighbor entries is there for the remote learned, which is 100::1 here, pointing to the VXLAN 1.1.1.1. Yeah, that's all.